All right, so let's talk about subtraction. Yep.
Will we do the same for base 8?
Yeah. That's why I prefer to discuss in general first rather than going right into 2's complement and 10's complement. Okay. So subtraction with complements. So borrow method, which you do on paper, is a method that we commonly use. It's only efficient on paper, but we cannot do it on in the hardware. Okay. So in order to perform subtraction, the first step of subtracting two n-digit number m minus n. So m corresponds to minuend, m to the r's complement of the subtraction. So what you need to do is to perform m minus n, you first need to calculate the complement of n. Okay, n being the negative number here, you need to calculate its complement first. It could be r minus 1's complement, it could be r's complement. Okay, as I mentioned, we will mostly be dealing with 2's complement or the 10's complement. Okay, forget about 9's or 1's complement in real life. Okay, so what we do is m plus this negative number is replaced with the complement, the 2's complement or the 10's complement of the number. Okay, so this is what we need to do. We just need to be performing addition. Okay, the second thing, important factor, is when the number that you are subtracting is smaller than the number you are subtracting it from, when m is greater than n, the sum will always produce a carry, okay, which we need to discard. Okay, so we have to discard that carry to get the actual result m minus n. The third rule is, if you are subtracting a number which is greater than the number being subtracted from, if m is less than n, the sum does not produce an n carry, and the result, that sum result, would represent n minus m, which means the r's complement or the 2's or 10's complement of the sum. Okay, so what you need to do is, whatever the sum is generated, you need to calculate its complement and just represent with a negative sign. Okay, we'll see, it will be more clear when we'll see an example. So these are the three main steps that you need to do. Let's take an example, number 1. Let's try subtracting a decimal value 72532 minus 3250. So here 3250 is the number being subtracted. What we need to do is to convert or calculate the r's complement of 3250. Okay, so we are using 10's complement method. So first write m equals 72532. Next thing is n. You need to represent it for your own easiness. You can append a 0, the leading zeros, just to keep the number of digits same. Okay. What will be the 10's complement of this number? Again, leave least significant zeros unchanged, and the first non-zero digit should be subtracted from 10, and the remaining digits must be subtracted from 9. So what do we get? 0, 5, because the 5 has to be subtracted with 10 from 10, and the remaining 3 digits should be subtracted from 9. So 0, 5, 7, 6, 9. That would be the 10's complement of this number. Okay? Any question here so far? So we have a number m, and we also have a number n, which is the negative representation of the actual number. Okay, 96750 is a negative representation of the original number 3250. Now what we need to do is to simply add them together. Add what together? These two together, m and the 10's complement of n. When we add these two together, you get a result like this. And you see, a carry is generated. This carry has to be discarded according to the rule that I have mentioned before. When you discard this, it will give you 69282. You can also verify the result in your own phone's calculator when you perform 72532 minus 3250, you get the value 69282. Any question? Again, we are building up some basic knowledge that you are supposed to be having before we actually dive into our main discussion about the computer architecture. Everyone understood? Okay. Now let's take another example, the other way around, subtracting 3250 minus 72532. Now m is smaller than n here. Now again, represent m with the leading 0 just to be synchronized with the number of digits. We have n 72532. We need to take its tens complement because n is being negative here. Okay, so when you take the tens complement, it would result in something like this, 27468. Okay, now we need to do what? Add m and the tens complement of n. These two numbers has to be subtracted. Okay, when we subtract, we get 30718. Now again, this is not our result, okay, because m was smaller than n. So when m was smaller than n, remember this step. This represents the result. The sum represents the r's complement. Okay, so we need to take its r's complement again and just place a negative sign. So here, what we need to do next is take the r's complement, which means tens complement of this number. So when you take the tens complement of this number, what you will get? 10 minus 8 is again 2, and then rest of the digits must be subtracted from 9. So you get this thing. Exactly the same result which you get on calculator with 3250 minus 72532. You need to put the negative sign yourself. Get it? Any question here? Okay, so we are gradually proceeding towards our bonus activity after almost 3 slides. If you have any question, you can ask me. Otherwise, you might lose your bonus points, free points. Okay, so let's proceed ahead with the binary arithmetic, binary subtraction. Now we have these two numbers, x and y, represented in 7 bits. So we need to perform x minus y and y minus x using 2's complement. Okay, so let's start first with x minus y. We have x and then 2's complement of y. I'm directly writing it here. So the 2's complement of y, how do you calculate 2's complement? Keep the first least significant 1 as it is and invert all the remaining bits. So invert all the remaining bits. Okay. Now we need to calculate the sum of x and the 2's complement of y, which is this, and you can see it generated a carry. Okay, and that carry has to be discarded. You can simply discard it, so you will get the result this one. Now if you were to do it like simply, first of all, if I go back here, let me just copy the values x 1 0 1 0 1 0 0 and y 1 0 0 0 0 1 1. Okay, so I'm moving to my notepad. So what is this value in decimal? Can anybody convert quickly? Yep. So here, this is space is 1, 2, 4, 8, 16. 16 plus 4 is what? 20. 32, 64. So you have to add 64, 16, and 4, which makes it 84. You can quickly convert it. What about this one? So here 1, 2, which makes 3, 4, 8, 16, 32, 64. So 64 plus 3 is 67. Now what you're doing is 84 minus 67. What would be the answer? 17. But how do you represent it in 8 bits binary? No, 7 bit binary, because these are 7 bits.
0010001.
So in order to represent 17, so first of all, you know that 1 is represent 16, 8, 4, 2, 1. And then you can append the additional zeros, 1, 2, 3, 4, 5, 6, 7. Yep. And this is what we got here. Here. So you can also verify your results. Once you have the binary number, you can easily identify if the answer is correct or not by converting x and y into decimal and perform the subtraction, and then you can convert the result as well. Similarly, y minus x. So again, y would be kept same. We need to calculate the 2's complement of x. How do you calculate 2's complement of x? Keep all the least significant zeros unchanged until the first one, and invert all the bits. Then perform the sum. And when you perform sum, it represents something. Because how do you know? By looking at this number, y minus x, how do you know that you are subtracting a smaller number with a greater number? Because you need to understand that this sum must represent a correct value.
It's the 2's complement of the actual.
Yeah, it's a 2's complement, but how do you identify whether it's the correct value or not?
By converting it back to.
Yeah. So what do we need to do is either you can again check the value, what is the value of y, what is the value of x. So you know that y minus x means you are subtracting a larger number from the smaller number. And once you know that you are subtracting a larger number from a smaller number, so the sum would represent the 2's complement. So you need to take the 2's complement again to get the correct result. So what we need to do next is taking a 2's complement. So 1 will be kept same and everything will be inverted. So you get the same result which you had it here. Okay? So conversion of tens complement, 2's complement again is very important. One thing, a common mistake that most of you guys do is you always consider that taking 2's complement means you are taking a negative number. Number can be anything. It could be a positive, it could be negative. When you take its 2's complement, it will convert it into its opposite sign. So if the number is minus 2, and if you take its 2's complement, it will make it, the corresponding binary conversion will make it positive. Okay?